Okay, now we got recording going. So I do have a hard stop today at 12, so I think as people come in, we'll just kind of go ahead and get going on things. Welcome to the May SRS meeting. And Steve is out today, so I'm kind of hosting it. We're going to have a general discussion on walking systems for robots. So we'll just kind of dive into the normal stuff here. Let's see. Okay. So please mute your microphone unless you're actively sharing. Turn your cameras on. You've got the bandwidth for that. You can use the Zoom chat to ask questions, make comments, post links, and so forth. The chat will be posted with the video. Just a reminder not to share any proprietary information requiring post-meeting video edits. We don't want to have to hunt anyone down and kill them because they heard something they shouldn't. Our video is being provided by Zoom. We do record the meetings and post them to YouTube later. We loosely follow the agenda below. Yeah, we'll just kind of dive into that. The SRS Discord server is up and running. Click the community link to get on the homepage for the Seattle Robotics Society, and you'll get detailed instructions on how to connect to that. Haven't looked at it lately, but I do see notes coming in every once in a while. So there is a fair amount of activity on there. This does replace what was it we had before? So long ago, I don't remember. Anyway, it replaces our old chat system that we had decades ago. The SRS and Robothon merchandise store is still up and running. If you would like to buy a t-shirt, a mouse pad, a cup, a mug, a hat, a phone case, just about anything, you can pop over there. All the proceeds go to supporting the club. If there's a image you would like or a particular piece of merchandise that you don't see that you would like with a particular image on it, let us know. It's actually fairly easy to set that up. We just kind of went through and set up, hey, this looks like the most common stuff people would want. Donna is running a Build It with Arduino meetup group. Next meeting is Saturday, May 30th from 1 to 3 p.m. Yeah, this slide got a little tweak, but the QR code will take you to the page where you can sign up for that. Local maker spaces, not sure what Steve's got going with this slide. So we used to have a list of them there. Events coming up. There's a AI safety and awareness group in Seattle that they're going to meet on Sunday, May 3rd from 11 a.m. to 12:30 p.m. at the Seattle Public Library. And the topic is, where is AI in 2026 and where is it going? Snowco Makerspace also has regular meetups if you go to their website. That's up in the South Everett area. And yeah, just generally open discussion topics. We're going to do number 3 today, robot mobility systems. So we'll see when we get started. It'll probably be about 11 o'clock or so. Steve has put together a slide deck, and we'll just have a discussion on those. It looks pretty interesting. It's going to be essentially a set of videos going over the different methods of robot mobility. So May 16th will be a facilitated discussion in bio-inspired robots. If you notice, this calendar's a little open. Looks like May. Hang on, this is May. The slide is out of date. So we're doing robot mobility systems today. If you look, though, the rest of the year is pretty open. So Steve would really, really like it if somebody has a presentation, if you would get in touch with him and kind of coordinate doing a presentation. I don't think I've ever seen his calendar this not open, or excuse me, this open. So do that one. Solicit presenters. Yep, just working on that. The presentation today is robot mobility systems. You can see a bunch of them there. Wheels, legs, Mercator wheels, creepy crawly things. Okay, the Robothon group is still going strong. Our next event is going to be on August 22nd, 2026. It's going to be at the Punk Rock Flea Market. This is in Seattle. Let's see, this next. Yep, there we go. It's up on Capitol Hill. It's by Ada Books if you've been up in that area. And it will be on August 20th. The challenges we're going to do it's going to be mostly indoor challenges for this one. So it's going to be build challenges 1 and 2. That's the go around the square and out and back. Line maze, line following, mini sumo, autonomous only, pop can challenge. Will be co-staged with War, so the Western Allied Robotics Group. We haven't done this since pre-COVID days when we were in the Seattle Center. But War is the combat robotics. So they're going to have about, probably half, 2/3 of the building. We're going to have the other chunk of it. And this will be going on concurrently. Let's see. All I got to say on that one. Monthly tech ed topic. Not sure if Steve gave us one, so we may be skipping that one today. Quick review for next month. We use the same Zoom link every month, so if you've got the Zoom link and you're here today, it'll be good next month, next week, or next month, next year, or so forth. Double check it's changed once in the last couple years, so it does change occasionally. If you miss a meeting, it will be posted to the website. The SRS website has upcoming meeting details. If you remember a couple slides ago, we're still looking for presenters. Steve would really, really like it if somebody would present. There is a Build It with Arduino group that is meeting on the last Saturday of the month from 1 to 3 p.m. And yep, there's another plug in here for helping us find presenters. Steve really, really needs help finding presenters. With that, we've got around the room. Let me stop sharing for a moment. And does anybody have anything they would like to share? Just go ahead and actually at this point, go ahead and just either raise your hand or just chime in. I think we don't have a ton of, we got 10 people online.
So I put it in the chat, but you mentioned a couple of times the Build It with Arduino has moved to the fourth Thursday of the month, and it's in the evening from 7 to 9 p.m. And the next one will be on May 28th.
Thank you. If you could ping Steve with that note, that would be great. He didn't get the slides update. And what is this I see about Ada's technical books closing? That's like really sad. Did you have something on that, Gordon? Where'd you see that? And you're on mute, Gordon.
I saw it online. I don't think I can easily paste the link in here. It's on a different device.
Let me see if I can find that real quick. Hang on.
CapitolHillSeattle.com.
I belong to another group that meets up there monthly, and they've quit meeting there because they are closing. So,
yeah. So that's totally sad. That was a really unique spot. So there's the website, and they do say right on there, last day will be June 6th. Click below for information. Let's see. Does anybody know why they're closing or any more? I'm trying to see if I can spot it on the.
I'm assuming the internet.
Yeah. Let's see. Here's the Here's the closing post. Let's see. Yeah, it looks like the owner wants to spend more time with their family and pursue other things. And they were not able to find someone to take over the bookstore. That's a total bummer. Okay, well, on that note, does anybody have anything else they would like to share? Maybe something cheery.
Well, it's not something that we can go over in like in person on a meeting because there isn't time. But I posted a link to an absolutely amazing presentation, which is a collection of papers from MIT's Leslie Siebling and Keebling and a few other researchers on planning, visualization, and planning for robotics. It's in the
Cool.
it's in the chat there. Might be something worth using as a topic for discussion in the future, but it's
Okay.
I think it's really good and not totally impossible to understand. You have to kind of sit with it and think about it for a little while, like each
Yeah.
paragraph, and then slowly becomes clear over time. Or at least that's the way it works in my brain, and you guys are probably smarter.
Actually, what I do is I read something and I go sleep on it and I understand it the next morning.
Exactly. Yeah, I've been reading Hans Morovik's book in the bathroom before I go to the toilet at night, sit down and read a few paragraphs of his book, and then I go to sleep and think about it and get up the next morning. It works much better.
Keep in mind, James, we are recording this session, so.
Oh yeah, I contemplate on my pillow
There we
in my
go.
meditation studio, surrounded by beautiful things for a few minutes. Yeah. Anyway, my throne.
Okay. Does anyone have anything else? See if Steve has any videos and stuff in the slide deck. Oops. Nope, that was all of that slide deck. So let's see. Well, this might be a shorter meeting than normal.
Well, that James's link there, are there some pretty pictures we could get our appetite whetted?
Let's see. Let me
There's
see.
a lot of pretty pictures in there. Why don't we start with what we're going to do, and then if it peters out, you can start in on that. I don't. It's not
Okay.
the sort of thing that it requires a shift of thinking that I think is difficult to do in a short period of time. It's one of those kind of things where if you just read through it, you'll be like, that didn't make any sense at all. But if you like read a little bit of it and stop and really think about it, and then you read a little bit more. So I would caution you against trying to go through it in like one meeting or something because it's complicated.
Okay.
But we can take a shot at it if you want to later.
Okay. I guess if folks have no objections, then let's go ahead and dive into the main presentation for the meeting. I'll kind of guide it. This will be a little bit of, there's a lot of videos in this. Basically, what Steve did is he's got, and I haven't looked at all the videos yet either. He's got, the mobility, and then he's got a short, 2 to 5 minute video that goes with it, kind of demonstrating it and talking about it. So that'll take up a good chunk of time. So let me go get set up to do that. Let's see. Let's see here. All right, I will share a screen. Okay. So the first one, motorized wheels, easy to use. Let me, where'd the mouse go? Let's see how this is going to show up. Yep, and hang on, before we get into this, let me do one more thing. I didn't share the screen with audio. Fix that real quick. Okay, there we go.
I'm going to do a short video on this new robot toy I've been working on. It has two functions. It goes forward and it will spin in one direction for steering. It's driven by a pickaxe board, the same board that I used on the last design I put out, and a Sony IR remote, or a universal remote sending out Sony codes. So here we go: forward, stop, reverse, forward, kind of goes in an arc. I'll try to explain that later, or what I think's happening with it. Now I'll explain a little about how it works. We have an N20 motor driving this bevel gear, driving these two bevel gears. When the motor drives this bevel gear, this one goes one direction, this one goes the opposite direction. The wheel over here is hooked straight to this gear, so when this motor is driven, like I say, forward direction, the wheel spins forward. When the motor drives this gear in the reverse direction, this wheel spins in reverse. This wheel will always spin in the same direction. I'll try to show you that. Forward, reverse, forward, reverse. This wheel is hooked directly, to this center section here with the ratchet mechanisms. This wheel is hooked directly to this gear. To explain it a little better, I'll show this part. We have the two gears in the center section, the two ratchet mechanisms. The wheels, or the gears, have a little ratchet here. So when this gear turns, let's say that this is the gear on this side that drives the wheel. When it turns this way, it catches and drives this shaft, which other wheel will be attached to. When it turns the other way, it will catch on this side and slip on that side. And that'll drive the shaft in the opposite direction. This is the first iteration I did of it. You can see the gears are turning in opposite directions. Now we're turning in the same direction. Kind of takes a minute to get your head around. This is based on a design I saw on YouTube on this YouTube channel. I'll put a link in the description of the video to that video. I'll also put a link in the video description showing the tutorial I used to design these bevel gears, which was quite a little adventure. But the tutorial was very good, and the gears worked in the end. Hopefully, when I get done, I hope for it to look something like this. Let me just zoom out a little. I hope it's showing up on the camera. I would like to use this dome right here. It's a 50 millimeter dome, as this up here, and have a body, probably with 3 AA cells. This is a battery holder out of one of those cheap dollar store flashlights that have 3 AA's on an LED in them. This is like 2.2 times scale, so it'll probably fit back here. Then maybe an arm, something like that. Maybe the arm would go up and down as it moved, or something like that. A little gun that moves back and forth. Not sure. I'll explain why I think it's turning in a small radius now. When it goes forward, whoops, when it goes forward, it seems to go in an arc. I believe the reason for that is these ratchets are springy, and when they load up and then they release as they go over each of these parts. So I believe it's like a little hammer action that actually drives that one wheel a little faster than the others. I may have to redo this ratchet design. Would have to do something that has a spring that just the force goes up and down and not around the center of the axle. Haven't quite figured that out yet. This is just early stages. You may be able to see that just a little bit as it. You can see it kind of hammers it as this side goes over the little ratchet mechanism. Well, thanks for watching. I just thought I'd show some progress on this.
Okay, so that's motorized wheels. I think we're all pretty familiar with that. Does anybody have anything they want to comment on for that? Hang on.
So I'm pretty sure that lots of people.
There. Don't need the next video. Okay.
I was really sad about Robert Murray Smith.
About what?
The guy that was about to play there, his name is Robert Murray Smith. Did a lot of really good videos, and then his wife died and he killed himself.
Oh, geez. We're having a sad meeting today, guys. Suicides and Ada Books closing.
Yeah, sorry about that. But I tell you what, you can honor his legacy by going back and watching his videos, which are pretty wild. They're not typically super I guess you could say he was a little bit loose with the facts or the applicability sometimes, like he would maybe slightly overhype things, but it really helps to break your head out of a box. Like he would go and give some kind of a presentation, he'd go, "Oh wow, I never thought about it that way," right? And so it's good. They're worth watching.
Hey, one question I actually had from that last video. For folks, if there's anybody on that's done 3D printing with gears, how effective really is that? I've always thought that's a little problematic. I see it done all the time. Does it generally work, or does anybody have any real hands-on experience with that?
Yeah, I've done a lot of that. So the first thing is to not just print regular gears, because regular gears really depend on like extremely precise fitment. The
Yeah, that's
better thing to
exactly
do
what I
is
was thinking.
yeah, the better thing to do is to print I think it's called a herringbone gear. Oh good lord, I don't have one handy right now. But basically what it is if you took a regular gear and you sliced it into little layers and you rotated each layer a tiny bit from the previous one.
Okay. Yep.
Okay, and then what you can do is do that like halfway through the gear and then reverse and go back the other way. And so you get this kind of a, I don't know what you call it. Somebody knows a name for it probably. But what's really
Herringbone.
yeah, okay, it is a herringbone gear. Good. My memory isn't completely gone yet. Um, so that really actually helps a lot. I'll see. I'll try to set up a shot here in a minute so you can see some of the stuff that we did with 3D printed gears on the robot, because that
Okay.
will inform.
Yeah, but with herringbone gears, sometimes it's difficult to get things fit together. You can't just slide the pieces into place.
Yeah, that's right. You have to slide the gears together and then put the shafts in.
Right.
I
Okay.
just wanted to mention, as long as you've got that four-wheel robot up there on the screen, there it went.
Yep.
That we made a robot that looked like that for one of the first challenges, and what we found was that the motors that we were given were not powerful enough to make that thing turn. And so
Hmm.
what we ended up doing is encasing the front wheels in epoxy so that they could slide on the carpet.
Oh, jeez.
And so then the back wheels were powerful enough to turn it. So yeah, be careful if you one of the things that I remember is someone was saying that think about the pedal cars that kids sit in and drive. You
Mm-hmm.
see a pedal tractor that is treaded vehicle. You never see a treaded one, and that's because by the time you got that to be strong enough that it wouldn't tear itself apart, it would be too heavy for a kid to operate.
Interesting.
Yeah, most of the vehicles that you see that are four wheels, they also have a steering component on the front two wheels, so you don't have that problem.
Right.
Mm-hmm.
What you're seeing there would require skid steering. And so, like another way you could do it would be to put holonomic wheels on two of them. And they wouldn't even, they wouldn't need to even be powered holonomic wheels. Actually, I guess the traditional holonomic wheel is powered on its driven axis and then slides freely on the cross axis. And that's just what you need.
It is
Okay.
impossible
Yeah,
to get a shot set. But I don't know if you can you see that gear right there, that one. I don't know if you can see that the teeth on it.
Can we blow your image up to full screen?
Which are you sharing something?
Yeah,
Oh, hang on. Let me stop sharing.
I'm trying to
See ya.
share a video here and it's just not working very well, but I'll try to just bring it
Where are you pointing?
closer by hand. This gear right here. God, I'm
Mm.
holding this whole robot in the air here and trying to focus at the same time. Talk about an ill-conceived idea.
Can we go full screen? Let's see. There's a button up here somewhere, right? I don't know I've forgotten how that works. Oh, here it is, view. Try the view button and go for speaker. There we go. Now you can show it again.
Yeah, so this guy right here is a differential on the end of the robot arm. Okay.
Mm.
And you can't really see it under this hood right here, but there's another one of these gears on the other side. And then there's a gear here, which forms the differential. Maybe you could see it better from underneath.
So that's not herringbone, but the
It's
teeth are
it's
slanted.
yeah, so it's a bevel gear,
Yes.
but instead of going herringbone on the bevel gear, it's the teeth are twisted, so it's like a half herringbone. Can't really see it. Sorry, I'll try to get a better picture or share a picture some other way. But that actually works quite well. The errors in the individual printings of the teeth sort of average out over time, if that makes sense.
Do they wear together and what do you call it? Wear in?
Yes, they do, and especially the if they're printed in a like a polycarbon fiber or anything that has embedded carbon fiber. What happens is the plastic will kind of wear away, and then the little figments of carbon fiber, which are stuck like half in the plastic and half out, those form an incredibly smooth surface. Yeah, works really pretty well. We actually built a whole drive set, a cycloidal drive out of that. So it's just, anyway, the point is, it's just a matter of adjusting the way that you print the gears. And if you look at 3D printed gears that are out there on like Thingiverse or whatever, you'll see how to do it correctly.
Yeah, okay.
Or correctly meaning in a way that works.
Okay.
Yeah, I've been 3D printing gears for quite a while now, and so I've got some planetary gears that I printed that work quite well. And let's see, I did a wave gear, which works quite well. I was surprised. And then I've been dealing with what do you call them? I can't even remember. Another type of gear, but it's not really a gear. Um, yeah. So 3D printing that kind of stuff can work for a while, but again, if you're looking for something that's got a long life, no, 3D printing's not going to last.
Yeah. Okay, cool. Thanks. All right, let me share a screen again, and we'll jump to the next one. Oops. Can you guys see that? Yeah. Yep, okay. It's not showing me my highlight on my side. Okay, dynamically balancing on two wheels. Okay.
Okay, I got questions.
Uh-huh.
How are we getting power to those wheels? Or is there some sort of chain driver? Until the guy put his arms in the video, I thought the thing was considerably smaller than it looked, than it turned out to be. But are there motors down driving the axles directly, or is there some sort of linkage up through that? Because that's pretty complicated if there's linkage.
Yeah, I'm not sure. I thought I saw maybe some belt drive in there.
I believe those are hoverboard motors.
Oh, motors in the wheels.
Yeah.
Oh.
There's sort of a halfway between a BLDC and a stepper motor, and they're used on those hoverboards.
Yeah.
Really cool motor. I actually really think there's a lot to be done with that.
So it's
That would make sense. You could
the stator is actually in the wheel. It's driving the axle, which is fixed on the body, and then the power leads come through the axle, right?
Exactly.
Yeah.
It would also be interesting to see how he's powering his linkage there. Presumably, there's just a motor inside.
Yeah, Steve just gave me the videos on this, so I don't have any background on
Right.
any of the stuff that's going on behind the scenes.
You can see there's a couple of wires coming out the linkage
Yep.
there.
Let me see if I can find a better shot of some of that.
If all
Yeah, that's a little blurry.
if all it's going to do is crouch, it could just use a single motor to.
There's a side shot. You can see some of the wires coming down.
Those look like individual wires now that you've got a better shot.
Curious if that type of balance can be achieved with a simple low budget 9-axis IMU. Anybody
I
know?
suspect so. I think where you put the IMU and how you orient it's going to be key, but I suspect so. You might need some feedback from the motors.
I've
Sure.
seen robots that use something considerably less, like they just use some sort of optical method to watch the floor or something. But an IMU would be nice if you could do it.
Okay.
Yeah, your cycle rate with the IMU for the controller would be pretty high in order to keep it balanced. So it's not 10 times a second, so probably 1,000 times a second.
I guess one of the things to mention is you want your center of mass to be as high as possible so that you reduce um, the resonant rate at which the thing will tip, right? If you put the weight far from the pivot, then you get a lower tip rate, and so you have more time to balance.
Right,
Yeah.
like balancing a long broom as opposed to balancing a short broom on your finger.
Right, or a long broom with a weight that's at the pivot. That doesn't work.
Okay, shall we do the next one?
Yeah.
Okay.
Holonomic wheel.
Well, yeah, so the one on the right is what we call holonomic. The one on the left is called mechanism.
Yep.
In fact, he's got it at the top there.
We'll do the first video. Maybe we'll do
Most mobile robots use wheels that perform well on even and structured ground, like in factories and warehouses. However, they face challenges traversing unstructured terrains such as stepped obstacles. In this work, we present the PATS wheel, a passively transformable single-part wheel designed for obstacle traversal. This novel hybrid wheel can surmount obstacles by transforming from a smooth wheel to one that can grip edges by using flexures that are passively actuated by contact forces. When choosing a wheel design for outdoor operation, there is a trade-off between terrain and obstacle traversability, ride smoothness, and efficiency. Wheels with larger tread and surface features, such as wheel legs or WEGs, can surmount higher obstacles, but suffer from vibration and power consumption issues on flat terrain. A variety of designs exist to capture the best of both worlds. However, none of them are simultaneously passive, bidirectional, or made from a single part. Our novel design of the PATS wheel is based on a force-reversing linkage, which has been turned into a flexure. This linkage is made up of a pad, claw, and coupler. When the pad is depressed, the claw extends. This allows the wheel to snag obstacle edges on rougher terrain while maintaining a round profile on smoother ground. Our wheel is constructed using a single print-in-place part, meaning that it is straightforward to scale to a new robot design. Linkage stiffness can be fine-tuned using the width of the flexure joints. We conducted several experiments to test our design against equivalent pure wheels and WEGs. The Pat's wheel significantly outperformed the WEG in terms of flat ground power consumption, and even slightly outperformed it in maximum obstacle height climbability. In terms of maximum climbing height, the Pure wheel achieved 25% of its diameter, the Pure WEG achieved 61%, and the Pat's wheel outperformed both at 70%. There was also no noticeable difference in the flat ground power consumption between our design and the Pure wheel. Additionally, when using our wheel, the robot experienced less vibrational energy than the WEG during driving, likely improving the longevity of the robot as well as its payload and accuracy of onboard sensors. Our results suggest that this new design combines the benefits of wheels and WEGs, and could be added to mobile robots to improve the capability and efficiency of locomotion and traversal in unstructured environments. Thank you for watching.
Okay.
I love that one. That's mechanical computing at its finest, right? Just figure out what the next thing is that needs to be done, and the machine just does it by itself.
I'm still waiting for my stair climbing Roomba.
Okay, let's see what we got for video 2.
Yo, what's up everybody, and welcome back to another video on my YouTube channel. My name is Lee, and this is Lee Curiosity. So today I will make a project about the mechanism wheels that you can control it with your smartphone. With the project, you will need some components to make this robot. The first thing is the Bluetooth motor. This is an HAL5. And the motor driver, an Arduino board. This is all 3 board, and 2 battery, a battery case, a switch, and 4 motors, and 4 mechanism wheels. For this project, this wheel is a little bit expensive, so I think that in the future I will design a 3D printed.
Can't hear this one really well. At least I can't.
That you can print it with if you have a 3D printer. And the last one that I want to thank you for spending time to watch my videos. I really appreciate that. And if you're new to my channel, you can consider to
Can you folks hear this one at all?
Lots of projects.
Not really.
I'm gonna jump it ahead a little bit and see if there's. This kind of shows him putting it together.
Are those? I can't tell from the size, but are those like AA cells?
Say again?
So are those AA cells or those 81? What is it? 18650? Those look like they're lipo cells on the thing. Maybe I'm just judging the size wrong. But I'm starting to see those. The comment that I wanted to make was I'm starting to see those show up more and more in projects. People just using, lipos as opposed to like AA's or whatever. And I guess it's a standard size. Now that he's holding it in his hands, I can see it.
Yeah, looks like so.
This is the first example of mechanism wheels that I've seen that appears to be using rubber rollers, so you get decent grip with these wheels. I haven't seen that before.
Yeah, that's nice. Did he say that those aren't 3D printed? I thought he said something about them being. I think he said you could 3D print them, but those don't look like they are.
Yeah, those don't look 3D printed at all.
He said they were expensive, so if he was to do it again, he would figure out how to 3D print them.
Yeah, I like I agree. The rubber is nice, and it actually looked like it responded pretty well. A lot of times when you're using those wheels and you see them like respond perfectly, it's because there's an IMU on board that's being used to correct the orientation automatically. But that one looked like it was just holding position correctly on its own, which is actually kind of rare with those. They tend to like, I don't know, skip and lose position and do weird things depending on like which wheel is the highest and whether or not the wheel is making contact or not. So I guess the rubber helps a little bit with that. He doesn't have any suspension, so that isn't helping. He's got a real flat table there.
The original design for the mechanism wheel, as I believe, was for use for a forklift tractor, which is fairly heavy, right? They
Right. Yeah.
typically have a ballast mounted on them so that they don't tip over, and so they have plenty of weight to keep the wheels in traction with the ground.
And they're working on a relatively flat surface,
Yeah,
you know,
yeah.
warehouse
This
floor or whatever.
pretty much requires a nice flat, like a factory floor, to make a decent.
There's a lot of those kind of things, right? Where it's like it looks really good. You see a video, you think, "Oh, I'll do that," and then you run into the, well, okay, under those conditions, but not under these conditions, and this brand, but not that brand, and at this weight, but not this weight. There's all these little gotchas.
Some nice mechanism wheels on Amazon for $50 a pop.
Ooh.
Okay, let's do this one. This is I'm
Esto.
gonna get into a couple of these. Yeah, Steve's got some interesting ones coming later in here. So this one looked pretty cool.
We've seen lots of Festo over the years, and they're known for really cool design.
Yep.
You look at those and go, "Oh, that's a render," and then they show you the real one, and you're like, wasn't that far off.
Right.
This one makes me wonder, is it purely a research robot, or do they have production applications for something like this?
I think a lot of these things Festo just does because they can. Okay, that was good. All right. Let's see. Okay. So here's some Boston Dynamics stuff.
Actually, that
Say again?
one on the one side was not Boston Dynamics, but anyway, it doesn't matter.
This project is trying to make simple walking robots. We have what we think is the simplest walking robot, consisting of just one actuator and two rigid bodies. There's two reasons we want to make these simple robots. One is to understand the fundamentals of locomotion. What are the principles that underlie locomotion of any animal or robot? And the second is so that we can make smaller robots. So we need to have simpler designs in order to make smaller robots that can walk. So small robots are good at getting into small spaces. So if you have a small crack or crevice, that's an entry into a collapsed building, and they're also good at things like industrial inspection, so getting inside of a complicated machine and looking for damage. We call this the Lego project because eventually we want to make something the size of a Lego minifig that can actually walk.
The robot itself, it's inspired by passive dynamic walkers, which are these little like toys that walk down slopes with gravity. We got to use part of the Lego Walker project, and the overarching goal of that project is to build walking robots at Lego minifigure size scales. And in order to do this, we investigated the question of how simple can we make walking as a behavior so that it's just easier to scale down. We don't have to deal with complex mechanisms. The way that the robot works is it lifts its leg forward, and then by doing that, it shifts its center of gravity forward, so it falls onto its front foot. And then when it contacts the ground with the front foot, because of the momentum forward, it allows it to shift onto that foot and give clearance for the next leg to swing through. And then as the next leg swings through, the center of gravity is shifted forward again, and that kind of produces an self-sustaining walking mechanism.
I worked with a lot of the experimentation and got a lot of first initial numbers on cost of transport. So I used a lot of the motion capture system, which is kind of a system of 20 cameras that pretty much captures every angle of the robot. And we put markers on the walker so that the cameras can see each rigid body's movement, even about the hip axis, so you can get accurate numbers when trying to do data analysis later on. So eventually getting numbers like cost of transport, what the most optimal frequency is when walking, and things like that.
I'm really excited about this project because we've really been able to simplify the design while still being able to have a robot that can start, stop, turn left, turn right, and maneuver around a space.
Okay. Thoughts or comments on that one?
I think that they didn't really talk about low power, but that's one of the really important things for that too, is it takes very little power.
Yep. All right. Yep. Treads. Okay.
Going from low power to high power.
Uh-huh.
G'day, I'm Mr. Code. Today we're going to check out how to build and code a driving base with Vex V5 tank treads and explore the process of turning Clawbot into this awesome beast. Stick around.
I don't know where Steve got these videos from.
Now let's talk about the benefits of tank treads. First off, they provide excellent traction, making it easier to navigate bumpy surfaces and maintain stability. This can be advantageous in scenarios where grip is crucial. With a variety of Vex V5 tread links, you can choose smoother conveyor links like the ones I'm using today, or treads with rubber inserts to increase the traction even further. To put together a basic tank tread, I'm going to use two C-channels to form the upper and lower halves, separated by 1-inch standoffs. The lower C-channel is shorter so that we can form this trapezoidal shape. This allows the front and back treads to climb over obstacles and maintain traction. Tank treads require a lot of torque, so I'm going to put two 200 RPM motors on each tread, driving a sprocket wheel each. Having all this power ensures that our robot will not be overheating very quickly. Next, I install the bogie wheels that run along the bottom of the track. Make sure that the wheels are protruding away from the channel before you screw them into place. Finally, I wrap the treads around the wheels and sprockets, making sure it isn't too loose or too tight. If you're enjoying this video, then please consider treading on that like button and subscribing to my channel. It is your support that lets me continue making Vex videos, so I thank you in advance. Once you have a pair of tank treads built, then it is time to link them together using some more C-channels. For my robot, I've taken the arm from the Clawbot and attached it to the top. Now you would think that setting up your tank to drive is as simple as adding a 4-motor drivetrain to your devices. While this will allow you to drive with a controller, you will also need to set your wheel size correctly in order for your autonomous code to function properly. If you are using these tank tread sprockets like me, they are 1.5 inches in diameter, which is not a selection that you can choose in VEX code. So you will need to write your own functions to drive accurately. I've created a simple tank drive code with blocks that you can download via my GitHub link below. All you need to do is set up your motor groups correctly in your devices menu before you enter your sprocket diameter at the start of your code, and then you'll be able to get your robot to drive the correct distance in autonomous mode. My Robotics Center Creator Academy is dedicated to teaching kids about coding and robotics, and I will be personally leading 3 of our teams to Worlds 2024 in Dallas, Texas. If your team is also headed to Worlds, then make sure you reach out to us in the comments section below. We love to share ideas and connect with other teams. And if you're in Australia, why not visit us at our Eastwood or Chatswood Robotics Center to see how we can support your child or school robotics team. Visit our website at www.creatoracademy.au.
Okay.
So I was trying to figure out the tread has a thickness, the drive wheel has a diameter. Which diameter is the right one to figure out how fast the tread's going to go on the ground? I think it's going to be the outer diameter of the tread as it goes over the drive wheel.
Yeah, that sounds that.
Because that's going to extend down. It really doesn't matter how big the bogies are. They're just holding the tread against the ground.
Mm-hmm. Yeah, I think that's correct. The only other one I could think is you think of the tread as actually the ground, and then it would just be the circumference of the drive wheel, as if the drive wheel was directly engaging the ground. It's the other
Yeah, I
way.
think that's right.
Oh, so that's different. That
It's slightly different, yeah.
It goes back to the whole thing about if your car, like your normal vehicle is driving down the road, if you think about it, there's a spot on the tire that's going from 60 miles an hour to 0 miles an hour every rotation of the wheel.
Right.
I made the mistake once of saying that to a guy who worked on tires for a living at a tire balancing facility, and it did not go well.
Oh, what you mean? He didn't believe it?
He did. It just blew his mind, and he couldn't believe it. I almost got thrown out of the shop, and I swear to God, I was being very polite.
Yeah. Okay. This one was one I really wanted to see. Let's see what we got here.
This vehicle is screw-driven and can move on snow, mud, and water. But what it was really designed for is not what you think. This is ZIL 2906, which was part of a Soviet search and rescue system dubbed Bluebird, designed to recover cosmonauts from the most inhospitable territories where no other vehicle could go. This vehicle was carried on the back of another vehicle for the most part, and upon reaching an impossible area, it was deployed to carry on with the search and rescue mission. The wheels were made up of a pair of large flanged cylinders, which also served as floats to move on water. One cylinder turns clockwise and the other counterclockwise. The counter rotations cancel each other out, which allows for the vehicle to move forward or backward. The ZIL 2906 had a top speed of 8.5 miles in mud and 15.5 miles in snow. But the only surface that this amphibious craft wouldn't drive on was paved roads, because it would destroy them, and it generally had trouble moving on hard surfaces, unless it was moving sideways.
So I don't know if you remember Charles Holzschuh. He came to a few SRS meetings. Stop it. There we go. He and I made a power tool racer that was based on this concept. We had seen a video of a Fordson tractor from the 20s that had been modified to drive a couple of pontoons like this with ribs along the edges. And so what we built was a power tool eraser that consisted of two power drills, the kind you would just plug into 120 volts, because power tool erasers are all driven from extension cords that come to a foot switch, and you initiate your run by hitting the foot switch. Well, so we had two power drills, each of which drove what do you call it? Quarter-inch hex rod that was bent around a say a 3-inch diameter piece of aluminum pipe that we got. And so we made two spirals with the ends of this rod bent so that they became pivots on either side. And they were bent to be counter rotating. And the driving drill was on the opposite end of each of these so that they balanced each other. And this thing would screw itself down the track, down the power tool racer track. The power tool race track has it's basically a plywood with a couple of 2x4s standing up on either edge and about a foot apart.
Hey, very cool. All right. Oh, this looks interesting. Walking cube. Oh, anything else on the screw stuff, folks?
That orange one looks like a kid's toy.
Yeah, it does.
Wicked.
Okay.
Now this one, those are reaction wheels, I believe.
I think so.
The Cubely takes its name from a combination of the English word cube and the Swiss German diminutive Li, indicating something of small size. With a side length of 15 centimeters, it mainly consists of 3 reaction wheels, each attached to a brushless DC motor, motor controllers, inertial sensors, an embedded processor, and batteries. Inertial sensor measurements are fused to get an estimate of the tilt and angular velocity of the Cubely, and the Hall sensors provide the angular velocity of the reaction wheels. Based on these estimates, a nonlinear controller is used to balance the Cubely on its corner, while the angular velocity of the reaction wheels is kept close to zero. Although this method of using reaction torques is similar to the one that is used to stabilize satellites in space, due to gravity, the algorithms used here are very different. With this setup, the Cubely can robustly balance around its corner while rejecting disturbances, rotate while balancing, and balance on its edge. In addition, the momentum wheels can rotate at very high angular velocities and build up sufficient angular momentum. A rapid braking of the wheel allows it to transfer the angular momentum to the Cubely's body. This allows the Cubely to jump up from a resting position to a balancing position without external support. Balancing on a corner is achieved through 2 subsequent jump-up maneuvers. The first maneuver raises a Cubely from one of its faces so that it balances along one of its edges, and the second raises it from its edge to one of its corners. In addition to balancing, the motor torques can be used to achieve a controlled fall, such that the Cubely can be commanded to fall in a specific direction. Combining these 3 abilities, jumping up, balancing, and controlled falling, allows the Cubely to walk across a surface. Some researchers hope to use this method of locomotion for planetary exploration, while others are using it for self-assembling robots. But for us, it is just a cool little cube that can jump up, balance, and walk.
Okay, that one was cool. Thoughts or comments on that one? All right. Wings. Hey, maybe we get some more. Yep, we're gonna get some more Festo in here.
A solar-powered winged robot has become the lightest machine capable of flying without being attached to a power source. Weighing just 259 milligrams, the insect-inspired RoboBX wing has 4 wings that flap 170 times per second. It has a wingspan of 3.5 centimeters and stands 6.5 centimeters high. The flying robot was developed by Noah Jaffers and his colleagues at Harvard University. Its wings are controlled by 2 muscle-like plates that contract when voltage passes through them. They are powered by 6 tiny solar cells weighing 10 milligrams each, which are located above the wings so as not to interfere with flight. The insect robot's wings begin flapping when exposed to light. Currently, it has only been tested in the lab, where it is powered by a combination of halogen and LED lighting. Limited by the positioning of the artificial lighting, the robot normally flies for around half a second before it leaves the field of light. The robot currently requires the equivalent of 3 times the intensity of natural sunlight, so isn't yet able to fly outside. The robot could one day be used for monitoring the environment or maneuvering through small spaces. It's very light for its size. If you need to land on a leaf, you could, whereas a commercial quadcopter would be too heavy to do that. In future versions, the team hopes to enable the robot to fly in sunlight and incorporate sensing mechanisms. It can then really control what it's doing when it's flying around.
All right, let's go get the other video. Okay.
Well, we never saw a close-up of the mechanism.
No.
It's
I
a circular gear on a little pinion with a motor, and then cranks that come off of both sides going to the wings. But there's some extra linkages that go out. The thing about that is it's absolutely beautiful and stunning, and it's an amazing achievement, but it still takes orders of magnitude more energy than a bird does. So
really
there's room for improvement.
So the left and right wing would have to be in synchrony. Do they have a way of
Yeah.
making one or the other wing not travel as far for each pass? That's how
There's
you.
a.
Right?
Sorry.
I'm just saying that's how you steer it. You have to be able to have a throw be adjustable.
Yeah, there's an RC servo in there that adjusts the linkage.
I would think the steerage would be done by the tail, rotating the tail.
There, there is a servo on the tail, but what we're talking about there is the adjusting the stroke of the wing, if that makes sense. The amount that it moves up and down, it changes it slightly. If I'm remembering that correctly, yeah, I remember seeing it and thinking, oh, interesting use of servos and also interesting use of linkages. So I may just have disremembered that, but I'm pretty sure I'm right.
Yeah, I suppose you could, if you had, I don't know what it would look like, but I guess you could imagine a belt crank and the pivot is moved a small amount by an extra servo, so that you change the throw by moving that the location of the pivot, so that you have the crank you were talking about, the drive motor's crank. It goes through a fixed throw, but then it's connected to a linkage where the pivot of that linkage is moved through a small arc or linear amount that changes the ultimate throw of the far end of that linkage. Something like that.
Okay.
Yeah, I'll post a link to the actual bird thing. What it is the other servo is used for wing warping. It doesn't change the stroke; it warps the tips.
Oh.
Okay.
Oh no, actually, wait a minute. I'm wrong. It doesn't warp the tips. Good Lord. Okay, so the main wings are actually completely they're just on a crank, just going. And the tip warping is happening as a result of air pressure on the wingtips, so they're slightly compliant. And then the two RC servos are twisting the tail and the neck, the head of the bird. Anyway, it's on that link that I posted in the chat if you want to see more on it.
Yeah, there's been a lot of work in the aerospace industry on wing warping for controlling aircraft at high and low speeds.
Okay.
What is the mechanism of that one you just were showing? Membrane style wings and some tiny actuator. What is that actuator?
Yeah, it's some little piezo or it's a very short stroke actuator from what I've seen.
The color that we can see there in the gap is the color of magnet wire, but or is that just the guy's finger showing through
Oh
with
no, that's the guy's finger showing through. Yeah, the
camera?
actuator is that little triangular segment.
Wow.
So it is a piezo. It's got to be a piezo.
It's a piezo something or other, or something similar to that. Yeah, you apply a voltage and it deflects.
The trick with those little tiny ones like that is I've never seen one that actually carries its battery. They always have a power wire going off to the side.
Yep.
So I keep waiting for that to happen. The only thing that's the smallest ones I've ever seen that carry their own power are little quadcopters, and they only fly for like 5-10 minutes. So I think that's really interesting that as they get smaller, power becomes more and more and more of a limiting factor.
Mm-hmm.
Yeah, I've got a little quadcopter with some small motors on it, and it only lasts about 7 minutes on a battery.
Yeah. And then you can get the big ones that can run for a long time. So
yeah, we were traveling through Europe and stopped in a small town, and they were shooting an action movie, and they were tracking one of the characters running through the alleyways and the streets in this very old town, cobblestone streets. And so they had this thing up in the air, flying overhead with a camera. But that was like a $10,000 quadcopter.
should I mention Ukraine? No, I shouldn't mention Ukraine. Pretend I didn't mention Ukraine.
Okay. With that, we'll move on to flippers. How's that?
The thing I always want to know about these flipper ones is how are they sealing everything and keeping all of the electronics working under the water?
Oops. I've seen that. I've seen them take these things apart. There's a lot of O-rings and pressure fittings and stuff in there.
Oh.
So
I think that's the magic part of the engineering is keeping it from leaking,
keeping the water out.
Yeah. That upper left picture with the wave-shaped wings on it, that reminds me of Strand Beast. Strand Beast has a generator that uses wind blowing over a pattern like that.
Yeah.
And the individual ribs are driving a crank, a multi what do you call it? Multiple cranks on a crankshaft.
That guy's my favorite kind of nutcase. Besto.
This one gives the impression that it's autonomous rather than controlled as well.
Okay.
So that looks like a two-motor vehicle, just left and right. And what the motors are driving are crankshafts.
Yeah.
The phase of the various cranks is what causes that sinusoidal shape.
Okay.
I don't know what they derive from the deflectable, in other words, not fixed, straight ribbed back. And if there's any control of that at all, why do they have that slight curve there in the picture?
Yeah, it didn't seem to be. Hard to say.
And what is the blue? in the middle there. What is that doing for you?
Well, when you watch the video and you watch the thing going along, the way they turn it is they stop flapping on one side and continue flapping on the other.
Right,
So
that's
that might
easier.
bend it a little bit and help the turn.
Hmm.
Yeah, again, it's like the difference between the wing being actuated and the wing responding to the air pressure, right? So if the
Yeah.
body responds to the actuators, then it's more or less the same thing. I'm trying to figure out in my head how they get it to maintain orientation, like
Oh, to keep
roll,
level.
pitch, and all that.
Yeah.
Yeah. There's got to be something about like the pattern of the motion, like maybe they I don't know, jerk it for a second when they know that the wave is towards the front or something.
Hmm.
There's a thing that you could do with quadcopter blades where you leave the blades slightly loose on the rotor head, and then they, as the motor is spinning the rotor around, they jerk it ever so slightly at certain very careful times, and then that makes the quadcopter actually move in different ways.
So real helicopters, they have to have the blades loose, not tightly mounted to the hub, because if they do mount them tightly to the hub, the thing will shake itself apart. But they don't seem to do that on small quadcopters.
Yeah. Okay. I'm going to move us to the next one here. So I've got about 35 minutes left and a couple more to go here. So,
Yeah, keep going.
okay, here's a propellers one.
Better at not falling over, since it could fly for a brief period to reorient itself. The idea came from watching birds. Most robotic designs focus exclusively on one type of locomotion, but birds are able to walk, fly, and even run. Leo will be doing a lot of jumping, with the propellers significantly augmenting both height and distance. Assistant Professor Alireza Ramazani, the designer of Leonardo, has also built a flying robot based on the aerial acrobatics of bats. That is another source of inspiration for Ramazani. Subscribe for daily robot videos.
Daily robot videos read in a robotic voice. What could be better?
Now, I think that one we just saw, well, it's the one on the right there. I think that those wheels are currently down and operating as wheels, but then they fold out and operate as propellers.
Yeah. I think that's what they're doing as well. It's either that or they've got the two in the middle could be propellers as
Yeah,
well.
those look like the propellers actually on that one, so I'm not sure. But the previous picture you had, the wheels were not vertical; they were like partially out.
Mm-hmm. Okay. Yeah, flippers and legs. Oh, the jellyfish, Festo jellyfish. This
Oh
one's
yeah, that's beautiful.
Someone saw this flying over the house and surely think it was invaded by aliens.
love that one. It's a great example of compliant mechanisms. And to your comment about aliens invading, I think, yeah, it works as long as the aliens don't invade on a windy day.
Okay.
Yeah,
So
that would be a good type of vehicle to have where you have a heavy atmosphere. Wouldn't work on Mars, but
Work
maybe
on
someplace
Jupiter.
like Jupiter or Saturn.
Venus.
Yeah.
That particular one depends on being very close to neutrally buoyant.
Yeah.
Yeah. So you have to have some kind of a pump inside that pumps it up or down in order to get close, and then it can do some motion.
Okay.
The ocean is full of power and information. The Wave Glider is designed to capture both. It's the world's most experienced ocean robot, propelled by wave and solar power. On the surface, the Wave Glider has everything needed for a self-contained data collection system. A powerful computing environment, scalable, flexible payloads, multiple communications options, solar panels and battery packs to power it all. The Wave Glider's innovation only begins at the surface. Below the surface is a sub attached by an umbilical cord that captures wave motion and transforms it into forward motion. As waves move the float up and down, wings on the sub rise and fall, propelling the vehicle forward. The slightest wave motion is enough. A solar electric thruster is available for extra speed when needed. Wave gliders can tow large payloads, hit speeds up to 3 knots, and be out at sea for many months at a time. Wave gliders have done some amazing things. They've crossed oceans, survived the toughest of conditions, gathered data from ocean depths to the surface, autonomously communicated with other assets, and even set a world record. All while delivering real-time ocean data, so our customers can make even more informed decisions. Discover what you can do with a Wave Glider at liquid-robotics.com.
Interesting, they're Boeing. All right, and let's see, video 2.
The ocean is full of power and information. The Wave Glider is designed to capture both.
Nah, I think this is the same video.
It's the world's most experienced ocean robot.
It is.
Propelled by wave and solar power. On the...
Say again?
Are you sure you clicked the other one?
Yeah, let me go back and try it again. Video 2. Nope, same video.
Maybe
A little longer though, so there might be something more at the end.
Yeah, maybe start in the middle or something.
Okay.
Speeds up to 3 knots. And be out at sea for many months at a time. Wave gliders have done some amazing things. They've crossed oceans, survived the toughest of conditions, gathered data from ocean depths to the surface,
maybe we
autonomously communicated with other assets, and even set a world record. All while delivering real-time ocean data, so our customers can make even more informed decisions. Discover what you can do with a Wave Glider at liquid-robotics.com.
Maybe we've only looked at video 2. Try video 1 again.
Okay. Nope, same one.
Okay.
The only thing I want to diagnose is how you're avoiding all of the commercials.
Huh? I'm using the Brave browser. I just switched, so it seems to be pretty good at avoiding all those.
Wow. Oh, there's a
Okay.
cool picture there showing an array of those wave gliders and the way they use a satellite to communicate with
Yep.
the anchor.
Maybe they can form a phased communications antenna.
All right, how about Gerbil Ball? Okay, this is a different video. We're good.
When the criminals see it, they say, balls.
Oh, that's a little bit of a ridiculous price.
I'm having a sense of deja vu here.
Yeah. But really, guys, I did not start the video over.
So the way you do that is you have your battery, the heaviest part of the bot, as close to the surface, the inner surface as possible, and you power that weight against the central pivot of the ball, and then if you can move that left and right, then you can bank basically to turn.
Yeah.
And this looks like somebody's done that with servos on a homebrew version.
Well, the next one actually takes it a step further.
Oh, yeah.
So, design for this one was in Make magazine a couple of years ago.
Oh, really?
So are they?
I had never done anything like this before, and I saw the movie Force Awakens, and I went.
Go ahead.
Well, I'm just trying to figure out what they're going to do to cause that the head to hover over the surface. You could imagine doing it with magnets, I guess, or with a slot. But
Yeah, I believe they do it with magnets. It's the ones I.
Yeah.
It's great for movies, but not overly practical is my take.
Yeah.
Hey, I want one of those. I'm gonna make one. And everyone thought I was crazy, but I just decided I was going to do it, and I found this club, and the rest is history. So my name is Sai, and I am a BB-8 builder on the side, and this is my BB-8, and I built it over the course of about 2 years. This little guy has taken thousands of hours of 3D printing, and everything is 3D printed, including the outside, the inside, the drive, absolutely everything. This is his head moving around here. I can spin his head. It's all controlled with an Arduino Mega. Everything is just a bunch of motors kind of wired up so that they move specific parts, which makes him bounce back and forth. I got him moving about 2 days ago. And one of the things that we noticed when we put everything inside of this ball is that there's some problems that we have to figure out. So I can't go forward and backwards because my axle is slipping. And I can't do a couple of other things.
I really think that actually really shows the maker spirit. It was working, I swear, it was working.
I know, every year I run into this. But yeah, and these are the head magnets. So these are really, really super strong neodymium magnets. And there's also going to be magnets in the dome. And so they'll sit on top of here and it'll roll around. But they're so strong that right now, if we put the dome on and they accidentally stick, they're going to shatter and not come apart at all.
All right, could we go check out that other one?
And everything is happening from this Arduino Mega right here. And so this is feeding out into absolutely everything. You've got your motor controllers, you've got voltage regulators, these giant servos that will rip apart this if you're not careful.
Those are really big servos.
Yeah. And then just all of your motors down here. So this is the one right here. Let me move that towards you. So the one at the very bottom is doing the side-to-side motion. And then this right here is what's moving it forwards and backwards. This little guy, this right here, is what's spinning the head around.
And you weren't kidding about everything being 3D printed. I can see the striations, all of this.
Yeah, the whole drive is 3D printed. Every single part that we could 3D print, we are 3D printing. I had to print my dome in 3 sections, and each section took 26 hours. So it was quite the endeavor. It's a lot of printing. A lot of printing. But if you're into 3D printing, or if you really want to learn about 3D printing, this is the way to do it. Yeah.
Well, you were telling me your background is not in electronics at all. Could you tell us a little bit more about that?
My background is in art. I work in animation and visual effects.
But electronics, all of your electronics that you've learned has been building this, basically.
Yeah, everything I've learned about robotics, 3D printing, electronics, all came from this project. I had never done anything like this before, and I saw the movie Force Awakens, and I went, hey, I want one of those, I'm going to make one. And everyone thought I was crazy, but I just decided I was going to do it, and I found this club, and the rest is history.
Okay.
The value of project-based learning.
Yep.
So
right.
I guess my question is, how do you hold on to the head without getting too much drag between the head and the body? Right?
The head has rollers on the underside of it against the body. So, and they're some kind of like either a captured ball, like a track
I guess
ball.
you could use ball casters, and if they're metal, then you could have them attracted by the magnet from inside.
Yeah, yeah.
What about the head possibly being like twiggy and having control or other computer aspects inside of it linked.
Oh, you could
have it bounce
transmit signals back and forth.
Well, yeah, communicate.
Yeah, why
Or
not?
radio.
Yeah, or you could, I don't know, pulse the magnetic field. One of your magnets could be an electromagnet. You could, or influenced by an electromagnet. You could transfer it that way, since you're doing magnetic coupling anyway.
Well, even with like Wi-Fi or Bluetooth communication links.
Sure.
Yeah.
And then also having the possibility of being able to speak, maybe like using the LLMs.
What you're talking about, the head is a separate robot which undertakes to stay on top.
Correct. You could actually detach it. And they would both still work.
Yeah, I like that idea.
Like the computer being attached in the head, linked wirelessly.
Mm-hmm.
What if the head, stay with me here. What if the head was a drone and it just perched on top of the ball?
Yeah, the ability of wings to come out of the circular surface.
Go back to that previous
transform.
Lloyd, can you go back to the previous picture?
That one?
There. They're showing a ball which consists of hexagonal sections that can separate and fly around. Each of them is a quadcopter.
There you go.
Oh, cool.
Well, shall we watch this video?
Oh, you got it. Yeah.
I have no idea what the video is, but the pictures look cool.
Researched by engineers at NASA Jet Propulsion Laboratory, the Shapeshifter is a flying, amphibious robot that could be used to explore terrains of distant worlds. Shapeshifter is versatile but also compact enough to launch on a rocket. Shapeshifter is made of smaller robots that can morph into rolling spheres, flying drones, swimming submersibles, and more. Each robot has a small propeller and is able to move independently. The engineers envision Shapeshifter as a mission to explore Saturn's moon Titan. The Cassini spacecraft flew by Titan over 100 times. Cassini was one of the most ambitious efforts ever mounted in planetary exploration. Cassini was a sophisticated robotic spacecraft sent to study Saturn and its complex system of rings and moons, such as Titan. On Titan, Cassini discovered a world surprisingly similar to Earth, but with key differences. Titan's cold rivers, lakes and rain are made of liquid methane and ethane. Titan could also conceal caves, or even icy volcanoes. The next NASA mission to Titan will be Dragonfly, which is scheduled to launch in 2026. Shapeshifter is part of a NASA early-stage research program. Even if selected, it could be many more years until Shapeshifter visits a moon like Titan. Subscribe for daily robot videos.
Okay.
Yeah, that's the one I was talking about. The angle, the wheels were at angles.
Yeah.
Oh.
And then they fold up, or they don't fold up, they fold out to become the propellers, yeah.
There was a whole movie called Transformers that did stuff like that.
Oh.
It's kind of weird seeing our youth, I don't know, morphed into something. Actually, there's a was it Unitree just did a sort of a transformer. Did you guys see that video? Anyway, go on. I'll see if I can find the video.
That's it. That's actually all the videos we've got. We've got about 10 minutes or so left. I don't know if folks want to keep chatting. I do have a hard stop at 12. If folks want to keep chatting, I can hand off the can stop the recording and hand off the host function to somebody. What would folks like to do?
Take a look at that video that I just posted into the chat if you want to see how Transformers are starting to come to life.
Okay, let's get back to that.
Hey, I've got a question while we're getting that set up. Does anybody know of a good source for high torque motors that are reasonably priced? I can find a lot of them that are hundreds of dollars, but I don't want to spend that much.
I guess what's the old thing? Cheap, fast, and good. You can pick any two or something.
Yeah, any two.
Yeah.
Yeah. I mean, if you want cheap motors, window actuators for cars.
Yeah.
Comes with a gear train, does everything. They're huge, they're powerful, they're not terribly expensive.
Yeah, and I've been using windshield wiper motors, same thing. They're a little bit bigger.
Yeah, exactly.
Not
So that sort of
terribly
thing.
efficient.
No, not terribly efficient.
Yeah, the other one that we had somebody do in the past was use motors from electric wheelchairs.
That's an idea.
That's not a bad idea. And actually, those hoverboard motors, you have to get a special driver for them, and they're a pain to work with. But what's nice about them is you don't have to gear them on the output. Like, you don't have to have a big drivetrain, and they are very efficient.
And depending on what size you're looking for, treadmills is another source. You can often find treadmills for free on Craigslist.
Yeah.
I'm sitting next to a 2-horsepower motor that was pulled out of a treadmill. You can run it off 24 volts roughly and get reasonable power out of it. Or of course you can run it off of higher voltages if you have a driver for it.
Yep.
Those are typically brushed DC motors. They're not terribly efficient, but good Lord, they're strong and they're free. I built a 1 foot square servo out of a motor like that, and it'll, with a gearbox on it, lift a human being off the ground. So solid steel 1 foot square servo, just for the fun of it. I figured people would really enjoy that and would use it to build big robots, but everybody was scared.
Yeah. The other one, if you want very high torques, we didn't use it as a motor. We actually used it as a generator. But the direct drive out of a horizontal washing machine.
Oh,
if you tear a washing machine apart, in the back of it, it's basically a fixed rotor, moving stator with magnets. It takes a fair amount to drive it. It's not, you're talking, plug in the wall type of thing.
Yeah, it's an AC motor though, right?
Strong, and they're about 1 kilowatt drive.
And they are AC, very high efficiency.
They're very high efficiency. They're strong. They're reliable. If anybody does that, disclaimer, be very careful. They're extremely dangerous.
Yeah. I think the question that I have is, the question I have on that is how you get it out, number one, and then how you mount it on something. That I would be very curious to see that actually done.
It looks like it just looks like a big flat pack motor. Is really what it looks like.
Oh, it's a flat pack.
It's
that's
flat
nice.
Pack.
Yeah.
Oh, cool.
Yeah.
All right, let us know what you do with that, Bob. I can't wait to see. And if we find out you're in the hospital, we'll know why.
No, I can guarantee it'll be for other reasons than that. But
anyway, if you watch this video, the guy that climbs in, they say he's kind of dumb. Somewhere in one of these videos, they say the guy's dumb. I think he's dumb because he crawls into this thing. But he does it while it's not running. And then when you actually see it running, the guy that's in there has a helmet on. So I thought that was kind of funny.
It's a mess.
And that, folks, is 100% real.
That's kind of like the robot they use on Avatar.
Oh, yeah. Anyway, we went from the 1980s cartoon to the, I don't know, 2K movies to now Unitree is actually building something. So,
yeah. Okay, we got just a couple minutes left, and I do need to get going. But does anybody want to take over the host role? Okay, stop sharing here a bit.
always a joy hanging out with you guys. I'll see you around.
Yep. Okay, thanks, folks, and have a good weekend.
Take care, everyone.
Take care.
Have a great one.